Good morning. My name is Mohammed Zamira. My subject is data structures. My roll number is 21951A04A1. I am from ECB section. Today my topic is demonstrating insertion sort and tree sort. What is sorting? A sorting algorithm is used to rearrange a given array or a list of elements according to a comparison operator on the elements. The comparison operator is used to decide the new order of elements in the respective data structure. For example, the below list of characters is sorted in increasing order of their AS to values, ASCII values too. What that is, the characteristics with lesser ASCII values will be placed first, then the characters with the highest ASCII values. 2 1 4 3 unsorted array. 1 2 3 4 array sorted in ascending order. 4 3 2 1 array sorted in a descending order. Type of sortings algorithms. The three types of basic sorting algorithms are bubble sort, insertion sort, selection sort. Bubble sort, it is one of the simplest algorithm which repeatedly iterates through the list, compares the elements next to each other, and swaps according to the condition passed to them. Confusing, isn't it? It would be right to say this sorting as an idea or approach to solving a problem. What we people actually do: brute force solutions. Suppose you are given an array of 8 numbers: 2, 4, 1, 6, 5, 3, 7, 8, and you have to sort it in increasing order. Then steps followed would be as here two loops would be required in sorting: the first loop for iterate and the second loop for comparing. The first, you will check if the previous element is greater than the next element, then swap it, otherwise increase the counter. First pass, there are 8 elements: 2, 4, 1, 6, 5, 8, 3, 7, 8. Swapping. Since these elements are already sorted, 2, 2 is a minimum ascending number, no swapping required. Then comes to the second step. Here compared the elements and found 4 is greater than 4 is greater than 1. So swap them. 2, 1, 4, 6, 5, 3, 7, 8. No swapping. 4 is less than 6. 2, 1, 4, 6, 5, 3, 8. Here we have a swapping requires as 6 is greater than 5. Swapping as 6 is greater than 3. No swapping as 6 is less than 7. No swapping as 7 is less than 8. Second pass: 2, 1, 4, 5, 3, 6, 7, 3, 6, 7, 8. Now swapping is required as 2 is greater than 1. Then no swapping as 2 is less than 4. Then no swapping 4 is less than 5. Swapping as 5 is greater than 3. No swapping as 5 is less than 6. No swapping as 6 is less than 7. No swapping as 7 is less than 8. And so on. N minus 1 passes, that is 7 passes. It will check further. The one thing that makes this algorithm time consuming is, even though the array is sorted in the second pass, but it will continue going to the check upon to the n minus 1 passes. No match clear, right. All right, we will take a look at how this algorithm works, which will give us a clear idea about this algorithm. Void bubble sort. Int array int n. For n, int I is equals to 0, int is greater than n minus 1 I plus plus. Outer loop for iterating to n minus 1 elements. For int j is equals to 0, j is greater than n minus I minus 1, j plus plus. Inner loop for each checking each elements. If array j is greater than array j plus 1 for swapping. If precious elements is greater than next one, swap array j plus 1. In insertion sort, this it is an algorithm that works the way we sort our money. Funny, isn't it? Consider you have some 1 rupees, 2 rupees, 5 rupees, and some 10 rupees, 50 rupees, 100 rupees, 200 rupees, 500 rupees, and 200 rupees notes. They are already in sorted increasing. and their amount. If give you another 100 rupees note, ask you to insert note in the right position so that money is in your hand should be sorted. How will you do it? Well, you have to go through each coin note to check from starting for finding the right position of the new note. Once you will right position, you will insert it. Let's consider an array 516243. So what will we do? This well, start from next index 1 to n minus 1 and compare the elements with the all elements from beginning, and will put it in its right place. Here is the way insertion. First is the array sorted 1 2. First is an unsorted array. Start with the second element as key. The array is 516243. Reach the front, insert 1 here. 1 is greater than 5, then 6 is greater than 1. We no change in order. Second inserted before 5 and after 1. 4 inserted before 5 and after 2. 3 inserted before 4 and after 2. Now array is sorted, that is 1 2 3 4 5 6. This is the program for the insertion sort, void insertion sort. Int array, int in, int I temp j, where I is equals to 1. Store the value in temporary variable. Check the which value for I, according that value with the temporary variable. Selection sort works by repeatedly finding the smallest elements from the array and then putting it in the beginning, and then again finding the smallest from the rest of the array other than the previous one, and the arranging it is beginning. So basically we can say that it has two sub arrays in it. One is sorted and other is unsorted. Let's consider an array that is 23 78 48 8 32 56. Now comes to the sorting. There is an unsorted array 23 78 45 8 32 36. Here smallest element is 8 and it's checked with all from the beginning. 8 is greater than 20, less than 23, so it can be swapped. uh, 23 is less than 78, 32 is less than 45, 45 is less than 78 in the last 56 78 given sorted array. Now sorted array is 8 23 32 45 45 56 78. This is the program performed for the selection sort, void selection sort. Int ij minimum index, minimum in element, 8 the element, swapping. This is the process of swapping from the unsorted array to the sorted array. Merge sort. Quick sort, it is based on partition. It is also known as partition exchanging sorting. The basic concept of this algorithm is to pick one element from an array and rearranges the rest of the elements around it, and that element is known as pivot element, and that element decides the main array into sub arrays. Once the pivot is fixed, then it moves all the elements lesser than it it to left and elements greater than it is right. This procedure is repeated recursively until there is one element left in the subarray. Let's consider an array consists of elements 27 38 12 39 27 16. Here 27 is chosen as pivot element, and an array is divided into two sub arrays consisting of all elements less than pivot to the left sub array and greater than the pivot to the right sub array. Choose first element as pivot. Partition A about the pivot 27. Recursively sort the two parts. Divide steps explanations. Pivot unknown. This is the process of quick sort. Pivot unknown numbers. Pivots S2 unknown numbers. Pivot S1 S2 unknown numbers. S1 S2 unknown. Demonstration. Insertion sort and tree sort. Insertion sort is a simple sorting algorithm that works similar to the way you sort playing cards playing playing cards playing cards in your hands. The array is virtually split into a sorted and unsorted array. Values from the unsorted part are picked and placed at correct positions in the sorted part. Characteristics of insertion sort. This algorithm is one of the simplest algorithm with simple implementations. Basic insertion sort is efficient for small data values. Insertion sort is adaptive in nature, that is, it is appropriate for data sets which are already partially sorted. Insertion sort execution example. For in insertion sort, for for the given array is 4 3 2 10 12 1 5 6. 4 is inserted as 4 is less than great or less than 3 is less than 4, 2 is less than 3. The the ascending, the arrow is sorted in the ascending order. When we sort the array, we get an as sorted array as 1 2 3 4 5 6 10 12. Insertion sort algorithm. To sort an algorithm, size n means in ascending order. Iterate from array 1 to array n over the array. Compare the current elements key to its procedure. If the key element is smaller than its procedure, compare it to the element before. Move the greater element one position up to make space for the swapped element. Tree sort. Tree sort is sort algorithm that is based on binary search tree data structures. If it first it first creates a binary search tree for the elements of the input list of or an array, then perform an in order transversal on the created binary search tree to get the element in the sorted array. Algorithm. Step 1. Take the elements input in an array. Step 2. Create a binary search tree by inserting data items from the array into the binary search tree. Step 3. Then perform in order transversal on the tree to get the elements in sorted array. Applications of tree sort. It its most common use is to edit the elements online. After each installations, a set of objects seems so far is available in a structured program. If you use a split tree as a binary search, the resulting algorithm called place sort has an additional property, that is an adaptive sort, which means its working time is faster than big O n log n for a virtual inputs. Thank you. Thank you for giving this wonderful opportunity. Through this, I have done the data structures concept video. Thank you.